Okay, so putting up the slide again, because I think repetition helps. While loop syntax, I think most students are getting the syntax correct, but you put the keyword while, whatever condition in between the parentheses must come out to true or false. And then any code inside of the curly braces, it's what will run. I've seen some students put some of their while loop code outside the curly braces and then wondering why it's not repeating. You need the code to be inside the curly braces if you want it to repeat while the condition is true. The other thing I noticed looking at people's code, sometimes students put an else statement after the while loop. Else statements only work with if statements. So it's like if, else. With while loops, the only thing you need is the while. And the code will keep repeating while the condition is true. And then once it becomes false, then any code after the curly brace will run. Any questions there? Okay. So on Friday, we came up with 2 requirements for a while loop. Does anyone remember what one of the requirements are? Yes, so both of you are right. It can't be infinite. So another way of putting that is that the conditional expression might be true initially, but eventually at some point has to become false. So we can't do something like 5 is greater than 3, because that will always be true. But we could do something like counter is greater than 3, because that eventually could become false. So generally that involves using a variable. And then what's the second thing that has to happen inside of the loop? Yeah, so you have to generalize that a little bit because that works for the counting examples. To generalize it, it's just we have to modify the chosen variable in some way. So if it's a counting loop, then we have to increase or decrease the variable. If it's a validation loop, which again we'll cover more in detail, if it's a validation loop, you have to keep getting inputs from the user. Do these 2 points make sense? If either of these aren't there, you'll end up with an infinite loop where it'll keep running forever. Okay, so let's start off with counting loops. Generally, the way you'll know it's a counting loop is if you know how many times the loop is going to run before the loop starts. So in the example where we wanted to print out Morehouse 3 times, how many times is that loop going to run? 3. And even if we ask the user for the input, if we ask them, how many times do you want to print out Morehouse? And they said 10, we still know before the loop starts, it's going to run that many times. It's going to run 10 times or how many ever times the user inputs. So even if you ask the user for an input, it can still be a counting loop as long as you know how many times the loop will run. Generally with counting loops, the condition is some sort of numeric check. So something is greater than 0, some counter is less than some value. There's some sort of numerical check that usually involves a less than or greater than signs. And then the important thing inside the loop, you have to make sure you increase or decrease that variable. Any questions before we go into examples? Okay, so we did these examples on Friday, so I won't have you all go in groups again, but I'll give people 15 seconds to think about it before I ask for the answer. Really think about it. This would be something that would come up on an exam. Okay. So what should go, first off, how many times is this loop gonna run?
3 times.
Sorry, we want it, so we want it to run 3 times. What can we put in the condition to make sure it runs 3 times? Yeah, counter is less than or equal to 3. And what do we have to do in here?
Counter plus 3.
Counter plus 3?
Counter plus 1.
Yeah, so we'd have to set counter is equal to counter plus 1. Right, so the first time counter is 1, we print out Morehouse. Second time counter is 2, we print out Morehouse. Third time counter is 3, we print out Morehouse. And then the fourth time, when counter is equal to 4, that's no longer less than or equal to 3. So then we exit the loop. Any questions on that example?
Yeah, so the counter equals counter plus 1.
Yes.
Is there, so when it becomes the fourth time, it just becomes false.
So in conjunction, this line and this line. So this line is just adding 1 to the counter each time. So the counter starts at 1, and then it will become 2, then 3, then 4. And the reason why that's important is in this while loop condition, when counter is 1, 2, or 3, it'll still be true, and it will run. but when counter becomes 4, then this statement becomes false. And so then we skip everything in the loop, and if we had more code down here, that would run. If we didn't have this line, then 1 would always be less than or equal to 3, and it would be an infinite loop, and we'd print out Morehouse forever. Okay, second example, even numbers from 0 to 20. Again, I'll give people 15 seconds to think about it. All right, so the first thing you should ask if it's a counting question is how far do we want to go up till or down till? So how high do we want to go up to in this problem?
20.
Yeah, because we want to print out 0, 2, 4, 6, all the way up to 20. So what can we put in the condition? What's less than or equal to 20? Even number. Why are we not doing counters less than or equal to 20? Yeah, so one thing I noticed in people's code, like they always use counter. Counter is a good variable name if, like, in the example of printing out Morehouse, we were literally just counting by 1. In this case, like, even number would be a better name for the variable because it makes it clear what the variable is doing. And so the condition we're putting here is even number less than or equal to 20. And then what do we do here to just get the even numbers?
Even number equals even number plus 2.
Yeah, exactly. So we're starting at 0, and we're doing 0, 2, 4, 6, 8. It will keep counting up until we get to 20. That will still print 20. Then when we get to 22, 22 will no longer be less than 20, so we stop. Any questions here? So note, when you increase it, it doesn't always have to be by 1. It could be by the value that makes sense for the problem. Does it matter the order of these two lines? Like if we switch these two lines, would the code still be okay?
Yeah.
Some yeses, some
Or
nos.
no, because that's the whole point of the while loop, right? Has to be in that format.
So let's see it through an example because this is a very subtle point, but I think is very important. Visualizer. Also, I put the link for this visualizer in the EdStem, like in the important links and info, code visualizer. So I'd encourage you, especially if you want to like really make sure you understand what the code is doing, that you put your code in the code visualizer. So let's put this in here. Include IOStream using namespace std. Okay, and I know we set up to 20, but that'll take a long time to step through, so let's just do it to 4. So what would we expect the output to be here? Yeah, so like 0, 2, and then 4. Let's visualize it to make sure we understand why. Okay, so what's even number after line 6 runs? Okay, and is even number less than or equal to 4?
Yes.
It's true. So we print out even number. So what gets printed here?
0.
Okay. And then what does even number get updated to?
2.
Cool. So people see that here, it got updated. And so now is 2 less than or equal to 4?
Yeah.
Yes. So we print out 2. And what does even number get changed to?
4.
Okay. 4 is less than or equal to 4. We print out 4. What does even number become? 6. And then back at line 8, is 6 less than or equal to 4? No, so that's false. So then we come to the end, and that's it. And so now the question was, what happens if we switch the order of this code? So again, the output we want is 0, 2, 4. Yeah, so this time, we'll step through it so that everyone follows. So even number, again, is going to be set to 0. 0 is less than or equal to 4. That's still true. Now, what happens to even number? Increases to 2. And so at line 10, what gets printed out? 2. So we skip 0, which is bad. That's not what we wanted. But one more error actually ends up happening. So is 2 less than or equal to 4? Yep. Even number gets changed to 4 here. So we print out 4. And then at line 8, is 4 less than or equal to 4? That's true. Line 9, what happens to even number? So it becomes 6. Note that the entire code block is going to run if the condition is true. It's not like every line it goes back and checks is even number less than or equal to 4. It only happens once each loop. So at this point, what is going to get printed? 6. Even though we only wanted to print it out up to 4. We ended up printing the value 6. And now it checks, is 6 less than or equal to 4? So now it's false, but now it's too late because the damage has already been done. So we actually ended up printing 246 instead of 024 when we switched the order of the lines. So generally, if we have a counting problem, we should generally increase the counter, or even number in this case, at the end of the loop, right before we do the check. The reason why we do that is the last line of the loop is the last thing that runs before we come back and do the check again. Right? Does that make sense? Okay. That's a pretty nuanced point. And I think if I just told you always put it at the end, you might not remember it. But hopefully this example will kind of stick of why it has to be at the end of the loop in most cases. And I think I had maybe in the first lecture updated the slide where I said for counting, we usually increase or decrease it usually at the end of the loop. Okay, one more counting problem example. So these first two problems, we were counting up to a value. This time we're doing a microwave countdown. So we want to do like 15, 14, 13, all the way down to like 5, 4, 3, 2, 1. And then we print out your food is ready. So I'll give people some time to think about this one.
So countdown. How would you try to count down?
Okay, so for this one, let's actually start with what goes in the while loop, and then we'll come back to the condition. So yeah, so to count down, we can do, instead of the other ones we were adding 1 or adding 2, this time we'll do time is equal to time minus 1. That way we get 15, 14, 13, 12. And what's the condition that we want to keep counting down for? Time is equal to 0, or because if time was equal to 0, this would never be true because 15 doesn't equal 0. So we would immediately say your food is ready. Yeah, so we want here time is greater than 0, just to show it up here. Because let's pretend the countdown was smaller. Let's say time was equal to 3. The first time 3 is greater than 0, so we print out 3. We reduce time to 2. 2 is greater than 0, so we print out 2. 1 is greater than 0, so we print out 1. And then 0 is not greater than 0. So at that point, we would come to the end and say your food is ready. Does that example make sense?
So you put time greater than 0 because...
So we're trying to think for what cases we want these two lines to run.
Mm-hmm.
And every time time is greater than 0, if you think about a microwave,
I hear you saying.
yeah, like so we print out like 15, 14, 13, 12. We'll keep going until 3, 2, 1, and then when it's 0, 0 is no longer greater than 0. And so that's our cue that your food is ready.
I got it.
Sweet. Any questions here? Okay, so again, just to recap counting loops, you know it's a counting loop if you know how many times it's going to run. How many times does this loop run? 15 times. How many times did print Morehouse 3 times run?
3.
How many times did print even numbers 0 to 20 run? 20 divided by 2 to 10 because we were increasing by 2 each time. But in each of those cases, we knew how many times it was going to run. We used that information to set up the condition. And in all 3 cases, we updated the variable in some way. So in this one, we decreased time by 1. In even number, we increased by 2. In counter, we increased by 1. Yep. Okay. Our other set of while loops are called validation while loops. And in these, we don't know how many times the loop will run. Why do we not know how many times the loop will run? Yeah.
Because it's dependent on user input.
Yeah, so we don't know if the user is going to get the password right on the first time, the 10th time, or the 100th time. So we can't tell before the loop starts how many times we need to run the loop. So that's usually your cue that it's a validation loop. And the condition is just, if the input is bad, then the condition should be true, because then we want to ask the user for another input. And make sure that you actually get new input from the user in the while loop, otherwise it will be an infinite loop. Yeah, question?
So like, well, are we gonna use validation while loop for the project?
So in Wordle, yes, because we essentially want the user to keep guessing a word until it matches the answer.
Also, it's not like a limit. I thought it was a limit.
So, and we're gonna put a limit of 6. So it's gonna combine counting and validation. Like that one will be 2 conditions. Like one condition will be the counting, where as long as guesses is less than 6, we keep running the loop. Or while the user has like the wrong guess. So like that'll be a little combination. We'll talk more about that later this week. Okay, so 2 practice problems here. Check for correct password. I'll give people a little bit of time to think about this one. Okay, so let's start with what should go in the loop so that we can keep getting values. So what should go in the loop there? Cn into attempt. So here we're not like increasing attempt by 1 or 2, like attempt is a string. So in the loop, if they get the password wrong and we ask them to try again, we want to store that in attempt again. And then what goes in the condition?
Attempt is exclamation point equals to ABC.
Yeah, so attempt doesn't equal ABC. So we want to think of the condition where when the user gives bad input, it comes out to true. And in this case, when attempt doesn't equal the correct password, ABC, that's true. Then we ask the user wrong attempt, wrong password, try again. And then notably, we store the new attempt in attempt so that we don't have an infinite loop. Does this example make sense?
Yes.
All right, last problem. Validate user's age is not negative. So if you're on a website, you input your age is like -8, the website should tell you that's not a valid age. That's what we're trying to model here. So let's first start with what line should go here.
Sin 8.
Yep, so we get a new age every time the user's age was invalid. And what's considered an invalid age? What can we put in condition?
Less than 0.
Yeah, so while age is less than 0, we tell the user, sorry, age must be positive, try again. So note that we are using like the less than symbol, and this is a numerical value, which kind of looks like the counting one. But in the counting example, like we were checking less than a number because we were like counting up or down to that number. This one, the reason why we're doing age is less than 0 is because that's bad input. So even in validation problems, like you can have a numerical check, but the reason for this numerical check is that age less than 0 is a bad input. That's why we use the less than symbol here. Again, though, we don't know if this is going to run 5 times, 10 times, 100 times. It depends on how many times the user messes up. Okay. Cool. Any questions on this problem? Or on the summary page? Counting versus validation. Counting, we know how many times the loop will run. We'll therefore use some sort of variable to count up or down. Make sure you increase or decrease that variable, usually at the end of the loop. Validation problems, we don't know how many times it will run. Make sure you keep getting inputs from the user so that they have opportunities to keep trying. Any questions here? All right, does it make sense? Cool. Sweet. So we're gonna get back into flowcharts, but this time I'm gonna have you all make the flowcharts. I think it's a little bit easier to see it as opposed to doing it. On the midterm, there will be one flowchart problem. It will be pretty similar difficulty to this, so I'll kind of be walking around to see how students are doing, so that I can see what I need to practice teaching more of going forward. All right, we're gonna do groups of 2. One person's gonna draw the first flowchart, and then someone's gonna draw the second flowchart. So pick whoever wants to go first. if you want to move over here. Austin, if you want to move over here. Let's have you two go together, and then we'll all have you join up with Ben. Well, the person who's not writing, still make sure that you're helping out. Jonah, I guess you want to join in here. Sorry, we'll have you guys do a group of three. Oh yeah, sorry, you can go. Okay. As a reminder, what does the rectangle shape symbolize? It's kind of like summary of action. So this can either be like get inputs, increase something by 1, whatever it is, just like a summary of what the code is doing. What does the diamond represent? What usually goes in the diamond?
Decision.
Yeah, so some sort of like condition will go in here. And the diamond usually corresponds to an if statement or a while loop. And then what do the arrows represent?
True or false.
Yeah, true or false, and generally just the order that the code runs.
No.
So you'll need each of these to do this problem.
Summary of action.
Alright, no, so we're doing the flowchart for this problem.
Don't slice it, don't slice it.
Counter less than.
False.
So the true would be like true is just oh true would be Morehouse. Yeah.
And then go down.
Make sure your flowcharts don't have infinite loops. I'm kind of seeing potentially some infinite loops. These flowcharts. So some you would need to just say how to change the counter.
Counter plus whenever it's out.
I know, but it don't get printed when it happens.
Oh, so we need to.
Like, is that like another box?
No, because that would be for the false one. Counter plus 1 only happens if it's false. Because if it's true, we don't add anything. So it'd be
This box is true.
yeah, that's not really true.
I don't know if the counter, but while it's true, you're pretty sure.
If it's true, you start.
While condition is less than or equal to 3.
Right, we have three.
If it's true, then it's no.
So that's true.
If it's true, then it's no. If it's true.
I mean, yeah, like, when it's false, we're gonna run out of like the program,
And on the false side, that's when we go
that's when
counter.
we would have it like printed.
Counter plus 1 and then we would loop it back to here.
Where do you put counter?
Wait, no.
In
When it's false.
where are you putting your print Morehouse?
No, like, so this is true because like, counter.
Oh, you're right.
The true state, the true section.
Yeah, so you could add another box on the true side for increasing counter.
Should probably label this as true and that's false.
Okay, so I can make this up.
Okay, I know people aren't fully done, but let's at least work with what you got so far. Okay. So what's the first like box thing before we get into the loop that we do here? So I should start from the top. So what's like the first thing we're doing?
Print Morehouse 3 times.
Okay, that's like the title of our flowchart, but we wouldn't put that in a rectangle, I guess.
Oh, okay.
Sorry. What's like the first thing that the code's doing? Yeah, so we'll just like set counter to 1, and then the code comes down. We have our like diamond, and what goes in the diamond?
Less than or equal to 3.
Yep. Counter is less than or equal to 3. And then this will either be true or false. What happens in the true case? First off, what in the code corresponds to true and what's false?
True. True is means it's less than true per more.
Yeah, so true is like everything in the curly braces, and false is everything after. We don't really have anything for the false case, so I don't know, we can just put like end program. This is kind of optional, you don't have to do that, but just for us to see. And then in the true case, we do 2 things. What's the first thing we do? Okay. And then what's the second thing we do? Increase counter. So this is what I meant by like make sure you don't have an infinite loop. Increase counter by 1. And then where does this arrow continue to? Yeah, kind of just like back to this code flow that's going to come back and check. So to see it here. So we set counter equal to 1 at the top. We check while counter is less than or equal to 3. This is true. We print Morehouse. We increase counter by 1. And then we come back and we do it again. And we keep doing it until it's false. And then we exit the program. Any questions here? Okay. Second problem. So hand the paper and pencil over to the other person. And then make sure you still help them out. So that first one was a counting problem. This one's a validation problem. But the flowchart will still look pretty similar. I'll leave that up.
Just in case, because I'm not sure, I should have put more copies in.
Can you put this in here? Or, I don't know, other box? What is your password?
Oh, we need to do like this. At the top. I mean, I get what you're saying. I get what you're saying. Once we get started with that portion, I'm just saying, we're trying to do like the first box right now. No. Because we're doing this at like that very start. So you probably have to see out first. What is the pass? That'll be that see out first. Okay.
Well, I can't do
I'll give people 1 more minute. Try to wrap up.
So first, yeah.
Okay, cool. It's okay if you're not completely finished. Let's kind of step through how this one will work. So at the top, I just ask the user for their password attempt. No, like you can draw 3 separate boxes if you want, where you say like define attempt, C out, what's your password, C in. Or like the nice thing with the rectangle boxes is you just kind of summarize what's going on. So at the top, we're just summarizing ask the user for password attempt. That will incorporate the C out and the C in. In our diamond, we say, well, attempt doesn't equal, I guess in the code it was doesn't equal ABC. So maybe in the flowchart here, I should also have attempt doesn't equal ABC. We have 2 cases. In the true case, I just summarized it as ask user for another attempt. So again, that will include the C out and the C in, where we say like, that's wrong, try again, try another attempt. I just summarized it in the rectangle. Note the arrows, it comes back, and it keeps checking this until when attempt is equal to password, then it will be false, and we allow website access. Does that make sense?
Yes.
All right, if your flowchart is different than this flowchart, do you understand why? Okay. Do you think you would be able to do this by yourself on an exam?
Maybe.
Maybe? Okay. We can, on Wednesday or Friday, try to do a couple more practice problems, just to make sure people feel comfortable with it. Cool. So, for the rest of class, we're going to use this motivating example of the number guesser game. So, we're going to have some random number. Can someone give me a random number?
21.
All right, 52, that's what I heard first. So we'll have 52 be our secret number. So if the user guesses something like 36, what should we print out?
Sorry, wrong number, try again.
Okay, and how can we be more specific?
Too high.
Yeah, so we can say like, sorry, too low, try again. If they guess a number like 78, what should we say? Too high, try again. And if they guess 52? Congrats. Cool. So if we wanted to make a flowchart for this, so this looks like a lot, but let's kind of step through and it should hopefully become simpler. Oops. Okay. So what's like the first thing we would want to do for this problem? Okay, so yeah, so we'll kind of assume that we know the secret number is 52, and here we'll ask user for a guess. Okay, and then this diamond, does this represent a while loop or an if statement?
Wow.
This one's kind of a while, right? Because we have and is this like a validation while or a counting while? Validation, because we're going to keep asking the user for guesses until they get it correct. So what's the condition we want to put in here? Yep, so we want a condition that will return true if the user input is bad. And in this case, any guess besides 52 is bad input. Let's start with the false case. So let's say guess were equal to 52. Then we'll say, yeah, print congrats. Yep, does that make sense so far?
Yeah.
Okay, so now let's do the true case. So guess doesn't equal 52. We come here, and we have another diamond.
Yes, less than 52.
Yeah, so this is this like an if statement or a while loop? Yeah, because we're just trying to figure out what to print inside of this while loop. So we're saying guess is less than 52. If that's true, what do we want to do?
Too low.
Print too low. Cool. And the else case? Okay. Why do we not Like, what do we do if it is equal to 52? Like, why did we not have to worry about that case here?
Because on the left side, there's a lot time.
Yeah, so if guess was 52, we would have just printed congrats. And there's no chance we can come here and then check if it's 52. So if we're in this while loop, at this part in the code, we know guess is less than 52 or it's greater than 52. But we know it can't be equal to 52. Does that make sense? That's pretty nuanced.
Yes, sir.
Okay. Okay. So in either case, so either we print it's too high either we print it's too high or we print it's too low. And then what's like the final thing we have to do in the while loop before we check guess again? Okay, what about attempt? Oh, yeah, so we have to like ask user for another guess. So it doesn't matter if their guess was too low or too high. When the code comes back together, we'll be asking the user for another guess. That way we don't end up in an infinite loop here. Does that flowchart make sense? Okay. And it seemed like people kind of got what we were putting in each one. My guess for what makes flowcharts hard is like figuring out the structure and the shapes to do. I think people are pretty good about filling in like what should go in the different shapes. Kind of the hard part that I think we maybe need a little bit more practice with is deciding what shapes to do. And generally, like, again, rectangles will be just a summary, so there's usually always something we start with at the beginning of the program. So almost always your first shape will be a rectangle. Then we generally have some sort of like condition where the code will do one thing or the other, either an if statement or a while loop. In this case, we put a nested if statement. So we put an if statement inside of the while loop flow. We did certain things, and then we came back. Yeah? Okay. So now let's put that example, into pseudocode. Wait, where did it go? Oh, shoot. What did I do to our flowchart? Oh, here it is. Okay. Okay. So we're going to put this flowchart into pseudocode. Can someone remind me what pseudocode is? Yeah, so it's pseudo kind of means fake, so it's like fake code. So it will look like real code, it will have the structure, but the syntax isn't going to be correct. So that's just to help us, because right now if we were to try to code this, it would be a little bit confusing because we have the diagram kind of going horizontal, whereas with normal code we write it vertically, line by line. And so it's pseudocode, we're going to convert this flowchart into that vertical line by line, but we're still going to do it in terms of summary. So what's the first thing that we do for this problem? What was the first thing we did? Yep. So ask user for a guess. And then what was the second thing?
Check if the guess is 52.
Okay. And is that a while or an if? Okay, so we'll use the keyword while. And I know in the video we watched on Friday, they didn't use like parentheses, but I think it's still nice to include. So we're saying while guess doesn't equal 52. Right? So later when you're to code this, you'll use the actual symbol for doesn't equal, which is the exclamation point equal. But in pseudocode, we want to make sure someone who doesn't code still knows what's going on. So we just kind of write it in English, while guess doesn't equal 52. What do we want to do in this case, while guess doesn't equal 52?
Check if guess is less than 52.
Okay? And so literally like what we just said right there in English. So if guess does it, or we'll say if guess is less than 52, then what do we want to do in here? Yeah. So I'll just use the English word print, but if you were to code it, you would use cout. Print guess is too low. Else, what do we want to do in the else case? Guess is too high. Cool. And then what's the last thing we want to do in the while loop? So outside of the if-else statement, right, as you can see, where the code has come back together, So we're outside the if-else statement. What's the thing we want to do?
Guess again.
Yeah, so we'll just say like, get another guess from user. So when you code this, you would know when you see the pseudocode that that means use cout and cin to get another guess from the user. Okay? So that finishes everything in the while loop here. We've checked all these diamonds and rectangles. So now we know like that's our cue to leave the curly brace. And what do we do outside of this curly brace? Yeah, so the loop's done, which means the user's guess does equal 52. So we would say like print congrats. Right? So note that like I didn't put like semicolons, I didn't use the right symbols. I just kind of wrote everything in English as summary. But this makes it much easier to write the code now. So on homework 5 that I'll release today, one of the homework problems is to write the code for number guesser. And so if you kind of get confused on how to do it, I'd come back and look at the pseudocode here. And ideally, this makes it a lot simpler to know what to do. Any questions here? Okay. Sweet. Engineers, like this isn't just something you do in school. Like for me, when I have to code at Google, I generally have to write out pseudocode before I actually start coding. And the reason is I can then show this to someone and they can be like, oh, I think this mostly makes sense, but how about this? And it's way easier to catch errors before you actually start coding than to code everything out and then realize maybe you have some error in your structure. So pseudocode is really important for making sure the structure of your code is correct, and it will help you when you go to start coding and you know what you're trying to do. Cool. So the last thing we're going to talk about is nested statements. We had talked a few lectures ago about nested if statements. So the syntax is all exactly the same. It's just you put that code inside existing curly braces. That's very similar to what we did with the pseudocode here, where we had this outer while loop that had this curly brace and this curly brace. So all the code between those two curly braces will run. And then we added a nested if-else statement inside of that. So looking at the syntax, like this is a normal while loop syntax that we've seen before. And what it would look like if we had a nested if statement would look like this, where like all the syntax is the same. Like this if-else statement, we had a slide for if-else that looked exactly like that. The only difference is we're putting it inside of a while loop, so everything gets indented one extra level over. So syntax-wise, it's exactly the same when you do a nested statement. It's just hard for students to conceptualize when you have this code running inside of another code block. And I don't really know if I have like a great way of teaching it. It really is just like practice. So we have the example of rock, paper, scissors, where you have your nested statement inside of whether the user's better or not. Number guesser, you have a nested if statement inside of a while loop. So this if statement is going to run every time the while loop condition is true. Yeah, does that make sense? Okay. Sweet. So that's all I have for lecture. Again, homework 4 is due tonight. If you need an extension, please email me before 10 p.m. And then lab 5 is due on Wednesday. If you haven't done lab 5, make sure you come into the lab today at 5 p.m. Yep, question? And I'll post homework 5 today. Yeah, question? Yeah, office hours will be from 3 to 5. Yep. And then if after office hours, let's say you only start working on your homework at like 7 p.m. and you have a question, you can still email me the question. It's not like you have to wait till Wednesday's office hours or Tuesday's office hours, right? You can still email me and I'll get back to you. Yep. Yeah, one sec.
I'm kind of confused on this part of the stuff.
Okay.
It's like apply a text that breaks all letters.
Okay.
But like I think we would have to use shard.
Uh-huh.
So we not have to like do shard letter 0, shard letter 1, shard letter 2.
Yeah. So how can we? So yeah, essentially we want to do it from like we want to do like char letter 0, 1, 2, 3, 4 to like get each letter in guess. So can you think about how we could set up like a while loop to get each of those numbers, like 0, 1, 2, 3, 4?
Okay. So this right here, for my condition, it wouldn't be get to 11.
Yeah, so like that part, that's just like an if statement. Like the guess equals answer isn't really like a while condition because we're just checking it once. So the code you write above is like your if statement. And then just to get each letter, that's like a while loop using some sort of counter variable to like get each letter in the word. Yeah.
We got to do the bonus question on log 5.
No. Yeah, you're good if you did that.
And what is index? Is like index like what our counter was?
Okay, yeah, like index is like technically the word we use for if you're getting like index 0, 1, 2, 3, 4 of a string. So yeah, index is like, you could use that instead of counter.
Okay. All right. Thank you.
Yep.
Do you know if this counts as an unofficial transfer?
Yep.
Like, but my name isn't on it?
Oh, is your name nowhere on
I
it?
could, hold on. I think, because my name was like, up there.
Okay. I would try to include the screenshot with the your name if possible.
So, but a screenshot is okay.
Yeah.
All right, because I didn't know like how it worked here. Because
Yeah.
my advisor didn't respond to my email.
Yeah.
But I can just take a screenshot of the page. That'll work.
Yeah.
All right. Thank you.
Hello.
Hi.
Yeah, I wasn't able to come to Friday class
Okay.
due to the cross country meet. Then
Yeah.
again, today when I was on